27th of May 1937. Dawn breaks over San Francisco Bay, and 18,000 people stand at the gates of a bridge engineers weren't certain would hold. You're there. The Golden Gate, 1.7 miles of suspension cable stretched across open water, the longest span on Earth, opens not to motor traffic, but to human weight alone. By noon, 200,000 bodies will cross. By the first hour's end, 15,000 footsteps per 60 minutes thunder across steel designed for 4,000 pounds per foot. This wasn't a celebration. It was an unplanned structural test conducted by a city desperate to believe. 3 months earlier, 10 men fell 200 feet to their deaths when scaffolding tore through the safety net. Chief Engineer Joseph Strauss watched his calculations face their harshest jury. Not wind loads or seismic forecasts, but the chaotic, unpredictable mass of humanity flooding his roadway. You'd hear the cables groaning. You'd feel the deck shifting beneath your feet. Subtle movements bridge spans make when loaded beyond their peacetime expectations. Each footfall added weight. Each surge of bodies pushed the structure towards limits no equation had fully accounted for. What the engineers witnessed in those first 6 hours forced a reckoning. Bridges aren't conquered by their builders on opening day. They're tested by the thousands who refuse to wait, who pay their 25 pence and march forward, transforming caution into history. This is the moment San Francisco chose faith over fear. Witness the walk that proved a city's worth, or exposed engineering hubris at civilization-shifting scale. You're standing at the southern approach to the Golden Gate Bridge. The year is 1937. Through AI reconstruction, we can now stand exactly where they stood, witness exactly what they witnessed. The 24 hours that changed civilization, rebuilt second by second. It's 5 a.m. The sky over San Francisco still carries the darkness of night. But along the Presidio shoreline, 18,000 silhouettes gather in queues that stretch for blocks. They've come to be first. First to walk the span civil engineers called impossible for 7 decades. First to test whether Joseph Strauss's 4-year gamble would hold or collapse into the Golden Gate Strait, 220 feet below. The bridge wasn't supposed to open to pedestrians first. That decision came late, a gesture to the community, officials claimed. But you'd notice something in the engineers' faces if you looked closely enough. Hesitation. The kind that comes when calculations meet reality for the first time. Behind you, the bridge towers rise 746 feet into the pre-dawn air, taller than any suspension structure yet built. 2 main cables, each 36 inches in diameter, arc between them. Inside each cable, 27,572 individual galvanized steel wires, spun together over months of precision work, 80,000 miles of wire total. Enough to wrap around Earth 3 times, but numbers on paper aren't the same as weight on steel. Joseph Strauss stands near the toll plaza, flanked by resident engineer Russell Cohn and a team of structural monitors positioned at quarter-mile intervals along the span. Strauss is 67 years old. He's spent 4 years on this project, 4 years battling skeptics, securing $35 million in funding during a depression, and watching 11 men die during construction. 19 others fell and survived, caught by the safety net Strauss insisted on installing at a cost of $130,000. They called themselves the Halfway to Hell Club, dark humor for men who knew how close they'd come to the bay below. But on 17th of February 1937, just 3 months ago, the net failed. A 5-ton scaffold broke loose during removal of wooden forms beneath the roadway. The massive platform fell, struck the net, and tore it apart. 12 men plunged into the water. 2 survived. 10 didn't. Strauss hasn't forgotten. You'd see it in how he checks his watch every few minutes, how his gaze moves from the crowd to the span to the monitoring stations positioned along the deck. The bridge was designed for vehicular loads, trucks, cars, predictable mechanical stress distributed according to engineering models. Not for 200,000 human beings moving in unpredictable surges, concentrating weight in patterns no formula fully anticipated. At 5:45 a.m., the first light touches the international orange paint coating the towers. The color wasn't Strauss's first choice. Consulting architect Irving Morrow championed it. Visibility in fog, aesthetic contrast against sky and water. practical beauty. The toll collectors take their positions. 25 cents per person. The fee was announced weeks ago, and no one complained. For a quarter, San Francisco residents would claim ownership of the span before official vehicles arrive tomorrow. 6:00 a.m. The gates open. You witness the exact moment when faith overpowers caution. 18,000 people surge forward. Not walking, rushing. Families, children, elderly couples, cyclists, even roller skaters. Within the first 30 seconds, the roadway fills with bodies moving in both directions across the 4,200-foot main span. Strauss watches from his station. He's holding a logbook. Beside him, Russell Cohn monitors the telegraph system connecting observation posts along the bridge.
Don't stop!
Every 15 minutes, they're supposed to report deck deflection measurements, cable tension indicators, and any unusual structural behavior. The first report arrives at 6:15 a.m. Deflection within predicted range. No anomalies.
Cable tension is at 70%.
Strauss doesn't relax.
Acknowledged. Recording
now. He writes
now.
the time and data in his logbook, then returns his attention to the span.
Deflection within
By 6:30
predicted
a.m.,
range, no
an
anomalies
estimated
reported.
5,000 people occupy
Time,
the bridge
6:15
simultaneously.
a.m.
The deck, designed with a width of 90 feet to accommodate 6 vehicle lanes, has become a pedestrian river flowing in both directions. You'd feel the vibration if you stood still long enough. Not violent shaking, but a constant hum transmitted through steel and concrete. The sound of thousands of footsteps synchronizing unintentionally with the structure's natural frequency. At the midpoint of the main span, 2,100 feet from either tower, an observation team records the first significant measurement. The deck has deflected downward by 7 feet.
The deflection readings
within
are critical.
tolerance, but approaching the
Double-check
upper
the
boundary of
calculations.
predictable behavior under distributed load.
Confirming readings now.
Strauss receives the telegraph at 6:45 a.m. He reads it twice, writes the data in his log, looks up at the span, now partially obscured by the crowd density. 7 feet. The bridge is sagging. This wasn't a failure. Suspension bridges are designed to flex, to absorb and distribute loads through cable tension and tower compression. But design tolerances and observed reality don't always align perfectly.
Look at the road!
Especially when the observed reality includes 200,000 human beings,
The yield
each
strength
weighing
holds.
between 100 and 200 pounds,
flexes by design.
moving across 1.7
Keep it
miles
steady.
of suspended roadway in patterns no engineer could simulate in 1937. At 7:00 a.m., 1 hour after opening, the count reaches 15,000 crossings. Not 15,000 people total, 15,000 one-way passages. Many have crossed, returned to the start, and crossed again. The bridge has become a loop, a circuit, a ritual. Children run. Elderly couples walk arm in arm. Photographers set up tripods at the midpoint, capturing the towers framed against the sunrise. Street vendors sell souvenirs near the toll plazas.
Come on, children.
A man
come
on
on.
roller skates weaves through the crowd at speeds that
beautiful,
make other
isn't it, dear?
pedestrians nervous. You'd hear the sounds layered atop one another. Conversations in English, Spanish, Cantonese, laughter, children shouting.
Welcome, friend.
The rhythmic click of
Souvenir
bicycle
flag for the
wheels on the
celebration?
expansion
They're
joints
lovely,
embedded
only a
every
few
few
coins.
hundred feet
Thank you,
along the
thank
deck.
you. Enjoy the day.
The groan of steel cables under tension,
wow.
audible if you listened carefully. A deep metallic hum like a bass note sustained indefinitely.
I agree completely.
And beneath
That's
it all,
fantastic.
the wind. The Golden Gate Strait
It's such a
funnels
wonderful
air
city.
between the Pacific
Absolute
Ocean and
princess.
San
Hi,
Francisco
Bangla.
Bay
Look,
with
it's
enough
so
force to
big.
require aerodynamic consideration in the bridge's design. On this morning,
Let's
the
go
wind
over there.
isn't violent, but it's present. You'd feel it pushing against your body as you walked, especially near the towers where the roadway rises highest above the water. Strauss checks his watch at 7:30 a.m. 3 telegraphs have arrived in the past hour. Deflection stable at 7 feet mid-span. Cable tension elevated but within operational limits. No structural distress signals from tower compression monitors. But there's something the telegraphs can't convey. Something Strauss can see from the southern approach but can't quantify. The bridge is moving, not collapsing. Moving, swaying laterally in response to wind and crowd distribution. Oscillations measured in inches, not feet. Barely perceptible unless you knew what to look for. He'd seen this before in scale models during design testing. Suspension bridges aren't rigid. They're dynamic structures that respond to environmental forces by flexing within tolerable ranges. The Golden Gate's design accounted for wind-induced motion, thermal expansion, and seismic activity. But 200,000 pedestrians? No one had tested that. By 8 a.m., the count approaches 30,000 crossings. The density on the deck begins to create bottlenecks near the towers, where pedestrians slow to photograph the view or simply stop to take in the sight of San Francisco Bay, 220 feet below. At the midpoint observation post, the team records a second deflection reading, 10 feet, 3 feet beyond the morning's baseline. Still within the absolute tolerance threshold, but approaching limits that make structural engineers nervous. Strauss receives the telegraph at 8:15 a.m. He doesn't write it in his log immediately. He stares at the numbers for 30 seconds. Then he walks to the nearest telephone and places a call to Leon Moisseiff in New York. Moisseiff is the suspension bridge expert who conceived the final design after Strauss's initial proposal, an ungainly double cantilever hybrid, was rejected. Moisseiff engineered the Manhattan Bridge.
Deflection data.
He understands cable dynamics better than anyone alive in 1937.
The deflection is nearly 10
the conversation
feet, and the crowd
lasts
count is
4
approaching
minutes.
critical mass.
No transcript exists,
What's
but
your
witnesses
professional
later
assessment,
reported
Doctor?
Strauss's tone.
Deflection 10
measured,
feet. Consulting
precise,
engineer advises
concerned,
continued
but not
monitoring,
panicked.
no action required unless
When he
exceeds
hangs
12
up, he
feet
returns
or
to his
lateral
logbook
oscillation
and writes,
intensifies.
Deflection 10 FT. Moisseiff advises continued monitoring. No action required unless exceeds 12 FT or lateral oscillation intensifies. 12 feet. That's the line. If the deck sags beyond 12 feet at midspan, they'll need to consider restricting access until the load decreases. But how do you tell 200,000 people to stop walking? At 9:10 a.m., the sun breaks fully over the East Bay Hills. The bridge gleams in morning light, international orange against blue sky and gray water. From above, if you could see it from an airplane, the structure would look like an artery pulsing with humanity.
2 inches towards
the
the
third
bay.
hour count,
Transmit this
45,000
immediately to character
crossings.
0001
The
at
rate
the
has
southern
slowed
approach.
slightly as the initial surge subsides and the crowd density stabilizes. But stabilize is relative. At any given moment, an estimated 8,000 to 10,000 people occupy the 1.7-mile span simultaneously. At the northern tower, an observation team notices something unusual. The tower's vertical alignment, measured against plumb lines installed during construction, shows a deflection of 2 inches toward the bay, within tolerance, but enough to telegraph to Strauss. He receives it at 9:20 a.m., writes it down, calculates
They are
the
not just
load
numbers.
implications. 2 inches of tower deflection under crowd load suggests the cable
The truth
tension has
is
increased
belief
beyond the static
built this
baseline by
bridge,
approximately
not just
15%. Not dangerous, not yet. But indicative of stress the structure wasn't experiencing yesterday when only construction vehicles crossed during final inspections. At 10 a.m., someone in the crowd begins singing. Others join. Within minutes, hundreds of voices carry a popular tune across the span. You'd hear it echoing off the water below, amplified by the bridge's acoustic properties, steel and concrete forming an unintentional amphitheater. Strauss hears it from the southern approach. For the first time that morning, he smiles. Not relief, recognition. These aren't numbers in a logbook. They're people. People who believe his bridge
How
will
does it
hold
feel
them.
watching
Belief
200,000
doesn't
people
reinforce
trust
steel,
your bridge?
but it built this bridge in the
It feels
first
like the
place.
heaviest
By
responsibility.
10:30 a.m., the deflection
The
reading
data is
stabilizes
promising,
at 11
but
feet.
we must exercise
No
caution
further increase in the
before
past
releasing
90 minutes,
definitive
despite
statements.
continued crossings.
You'll get your
The
answer
structure
then.
has found its
But I'll
equilibrium
only talk
under
at noon.
sustained load.
Noon, sir.
The cables
Noon.
have stretched to their new tension length. The deck has compressed the suspender ropes connecting it
halfway
to the
point
main
is reached.
cables.
We
The
have a
towers have
steady
absorbed
flow.
the increased
Okay,
downward
well,
force through their
9,000 in 6
massive
hours.
concrete and steel
Impressive.
foundations anchored 100 feet below the waterline. Everything is holding. But Strauss doesn't celebrate. He keeps watching, keeps logging, keeps waiting for the telegraph
No
that
failures,
says something
no
has
collapses,
gone wrong.
everything
It
holding within
doesn't come.
tolerance.
At 11:00 a.m., a journalist from the San
measurements are
Francisco
stable.
Chronicle approaches Strauss for comment.
Requesting authorization.
Mr. Strauss, how does it feel watching
Golden Gate Bridge
200,000
has
people
performed
trust your
exactly
bridge?
as designed.
Strauss doesn't answer
Pedestrian
immediately.
access will
He looks at the
continue
span,
throughout the day.
at the moving mass of humanity still flowing in both directions. Then he says, "Ask me at noon." Noon arrives. The count reaches 90,000 crossings. 6 hours since the gates opened. 6 hours of continuous foot traffic across a suspension span that, until today, had never supported more than a few dozen workers at once. The deflection holds at 11 feet. Cable tension elevated but stable. Tower alignment unchanged. No structural distress. No failures. No collapses. At 12:15 p.m., Strauss picks up the telephone again. This time he calls the Bridge District Board of Directors.
Isn't this just the perfect
The conversation
spot?
lasts 2 minutes.
Absolutely,
When
the
he hangs
kids
up,
seem to
he
love
issues a
it.
statement to the press
Can
gathered
I
near
have
the toll
another
plaza.
sandwich?
The Golden Gate Bridge has performed exactly as designed. Pedestrian
Let's get
access
one of
will
you now.
continue throughout the
Just
day.
like this?
But that wasn't
Yes,
the full
beautiful.
truth. The bridge had performed beyond what anyone designed for,
Watch out!
because
I'm
no one had
coming to
designed
get
for
you.
this.
Over here,
No one had
run.
run calculations
Got
for
you.
200,000 pedestrians. No one had modeled the load distribution of roller skaters and cyclists and children running at unpredictable intervals across 4,200 feet of suspended roadway. Strauss knew something the public didn't. They'd just conducted the most comprehensive stress test in suspension bridge history. Unplanned, uncontrolled, irreversible, and it worked. By 2 p.m.,
Lovely day
the
for
count
flowers,
surpasses
isn't it?
120,000.
I'll take this bouquet.
The pace
Wonderful
has slowed
choice.
as the initial
Here you
surge
are.
subsides,
Thank you.
but the
Enjoy
bridge
your
remains
day.
crowded.
Singing. I've
Families
crossed this
picnic
bridge
near the
1,000
towers.
times and every
Couples
journey
take
feels like
photographs.
home. Drums.
Children chase each other across the roadway,
Bass.
oblivious to the engineering marvel holding them 220 feet above water. At 3 p.m., the deflection reading drops to 9 feet. The crowd
The final
density
count
has
has
decreased
arrived.
enough to allow partial structural
202,000.
recovery. Suspension bridges don't snap back
Unprecedented
instantly.
success.
They relax gradually as load diminishes, the cables easing back toward their unloaded equilibrium. By 5 p.m., the count reaches 160,000. The afternoon has become a citywide festival. Vendors sell flowers and flags near the approaches. Musicians play near the toll plazas. The bridge has transformed from an engineering project into a public space, a commons suspended above the sea. At 6 p.m., 12 hours after opening, the final official count arrives. 202,000 crossings. Some estimates push higher, accounting for uncounted children and those who slipped through without paying the 25-cent fee. Strauss logs the number, closes his logbook, walks onto the bridge for the first time that day. You'd see him moving through the thinning crowd, a 67-year-old man in a suit, walking slowly, touching the railing occasionally, as if to confirm it's real. He reaches the midpoint at 6:30 p.m., stops, looks down at the water below, looks up at the cables arcing overhead, looks back toward San Francisco, where the city skyline glows in the setting sun. He'd survived the skeptics who said it couldn't be built, survived the funding battles, survived the construction accidents, survived the February disaster that killed 10 men, survived this morning's unplanned stress test that could have ended in catastrophe. Tomorrow, President Franklin D. Roosevelt will press a golden telegraph button in the White House, and the bridge will open to vehicular traffic. Ships will sound their horns. Church bells will ring. The world will celebrate. But today, this
Day
day,
ends peacefully.
belonged to 200,000
only a
people
few
who
remaining.
chose to believe before proof existed.
Let's secure the gates.
Strauss returns to the southern approach at 7 p.m. The crowd has thinned to a few hundred stragglers. The toll collectors prepare to close for the night. The observation teams dismantle their monitoring equipment. Russell Cohn approaches with the final deflection. Reading 3 feet. Nearly
Final
back to
deflection reading
baseline.
confirmed at
The
3
bridge
feet.
has recovered.
Structural recovery complete.
Should we draft a
Good.
report for
As
tomorrow's
expected.
opening? Cohn asks. Strauss considers. Then says,
Should we draft
"Write
a
this.
report for tomorrow's
Pedestrian
opening?
load test on
Yes,
27th of May
authorize it.
1937
After
demonstrated
reviewing the
structural
data, I can
integrity under
confirm the
sustained
12-hour
distributed weight
measurements indicate a
significantly
7%
exceeding design
deviation from the
parameters.
standard
No
projections.
failures. No modifications
Write this.
required.
Pedestrian
Proceed
load
with
test on
vehicular
27
opening
May
as scheduled.
1937 demonstrated
writes it down,
structural
reads it
integrity
back.
under sustained
Nods.
distributed weight significant.
That's accurate. Accurate, Strauss repeats.
It's accurate.
But
Designated for
incomplete.
matrix.
Sir, add this. Bridge performed beyond
Accurate.
expectation. Public confidence justified. The next
But,
morning, 28th of May,
but incomplete.
1937, the Golden Gate Bridge opens to motor traffic. President Roosevelt presses the telegraph button at noon Eastern Time, 9 a.m. in San Francisco. Every fire siren in the city sounds. Every church bell rings. Ships in the harbor blast their whistles. Foghorns bellow. Cars and lorries stream onto the span for the first time. The bridge handles the load without incident. The deflection under vehicular traffic never exceeds 5 feet, well below yesterday's pedestrian maximum. The Chronicle runs a headline: Golden Gate opens to traffic, bridge holds strong. But buried on page 4 is a smaller article. Engineers surprised by pedestrian test results. The article quotes an anonymous bridge official. "We knew the structure would support motor traffic. That's what it was designed for. But 200,000 people? That was unprecedented. We're fortunate the result wasn't different." Strauss never confirms or denies the quote, but in private correspondence with Leon Moissaieff later that summer, he writes, 27th May taught me something no calculation could predict. Bridges aren't conquered by their builders. They're proven by the people who trust them. Over the following months, structural engineers from around the world request the pedestrian load test data.
Add this.
Strauss provides
Bridge
it
performed
willingly.
beyond
The
expectation.
Golden Gate's performance
Public
under
confidence
unprecedented
justified.
distributed weight informs
27th May
suspension
taught me
bridge
something no
design for
calculation
decades
could
afterward.
predict. Bridges
but the
aren't
data only
conquered by
tells
their
part of the
builders.
story.
They're
The
proven
numbers
by the
can't
people who
capture the
trust them.
sound of 200,000
I
footsteps.
think that's the last one for May
The sight
27th
of children
data.
running across
Good, we're
a span
sharing
that didn't
unprecedented
exist a year
information
earlier.
to future suspension
The
bridges
feeling of
globally.
standing at the midpoint, 220 feet above water, and realizing that human belief, collective, irrational, beautiful belief, can carry
They
as much
capture
weight as
structural
steel.
behavior, but not the
By
sound of
1940,
200,000
more than
footsteps.
10 million
Not
vehicles
the children
had
nor
crossed
the
the Golden
feeling.
Gate Bridge.
Collective belief carries
By
weight.
1960, 50 million. By 1987, the bridge's 50th anniversary, organizers planned a second pedestrian day. They expected 50,000 people. 300,000 showed up. The crowd density flattened the deck by 7 feet. Engineers monitored nervously, remembering 1937. The bridge held. It always held. Joseph Strauss died in 1938, 1 year after the bridge opened. He was 68. The official cause? Myocardial infarction.
7
But
feet again.
colleagues later
Get the
suggested the 4-year
1937 data.
construction ordeal, the
Matching.
battles, the deaths, the stress of watching
An
his
elastic
life's work
response.
tested by 200,000 people in 6 hours had taken its toll. His legacy endures. The Golden Gate Bridge remains one of the most photographed structures on Earth. 89 years after opening, it carries 112,000 vehicles daily. The pedestrian walkway, opened on 27th May 1937, remains accessible. Thousands walk it annually, most unaware they're retracing the route of the 200,000 who tested it first. You've witnessed the 24 hours that transformed San Francisco's skyline and suspension bridge engineering worldwide. Through AI reconstruction, you stood where they stood, felt the deck shift beneath your feet, heard the cables groan under unprecedented weight, watched engineers hold their breath as belief confronted calculation and won. The Golden Gate's opening wasn't just the debut of a bridge. It was the moment a city chose to trust equations written by fallible humans and steel forged by imperfect hands. The moment 200,000 individuals became a collective test of structural faith. Engineering provides the calculations, but civilization provides the courage to walk across before anyone knows for certain it will hold. Which moment of these 24 hours would you have most wanted to witness? The first surge at dawn? The midpoint realization that it was holding? The engineers' faces when the final count arrived? Share your thoughts. Thank you for witnessing history with us. You were there. You witnessed the 6 hours that proved bridges aren't just steel and cable. They're built from belief as much as iron.